All right. Good morning, grade 9s. Yeah, let's get into this thing. Hey, we are in GEC week because this week we will be writing GEC, and those who will be writing GEC on the 13th of November, guys, this is for you. This is for you. These people who are writing on the 13th of November 2025, right? This is for you. We want to obviously now go ahead and cover the GEC content, right, for mathematics. We want to look at 2023 and 2024 starting today. We'll continue tomorrow, and hopefully we'll finish off on Wednesday, which is just a day before you guys are able to write, right? So officially we're starting with this. I do want you guys to know that whatever I do here will be uploaded onto the YouTube channel. So make it a point that you subscribe to the YouTube channel so that when I upload the video of this particular session, you can have the chance to watch it in your own time, at your own pace. So yeah, let's do this. I know that some of you may be writing maybe grade 9 or grade 8 or whatever, but guys, I want to just get into the groove of the GEC papers. Good morning, Smart Study. Good to see you. Good to have you. Good to have you in the live, and thanks for sharing the live. I see you share out the live to many people. In actual fact, I always see you share out the live, so thank you so much. Yeah, thank you so much for that. All right, so let's get into this. Let's get stuck in. So my grade 9s, this is like this week of paper 1 GEC, right? Maybe some of you are writing other papers today, that's fine, but I'm going to get into this. So let us get stuck in. We'll see how far we can go for today. Please double tap on the screen, like the live, guys, so that we can get this out to as many people as we possibly can. So let's start here on this page, guys. This is the guideline, the exam guideline for GEC Maths Paper 1 for grade 9s. Guys, we need to know these things here. Well, Swagtand, all the best. I'm sorry about that. Is that GEC as well, the 2-hour 30-minute English paper? Yeah. So guys, this is basically for grade 9. Grade 9, the Maths GEC paper will contain, as it says here, the following: numbers, operations, and relationships. So you guys need to know everything about the number system, all right? Distinguishing between natural numbers, whole numbers, integers, rational numbers, irrational numbers. All right, and if you need to know real numbers, you need to know non-real numbers, you need to know undefined numbers. These are things you need to know. Then you need to know multiples and factors, the use of the prime factorization of numbers, LCM, HCF. You guys need to know that. Solving problems, solving problems in the context of ratio, rate, direct, indirect, and finance. You need to know that. Integers, calculations involving integers, exponents, guys, you need to know that. And patterns and number patterns, investigating number patterns, looking for relationships, representing your number patterns in physical or diagram form, with those that involve a constant difference, a constant ratio, and represented in tables and represented algebraically. Okay, so you need to know all of this. So these people who are joining the live, and you guys can't necessarily be here now because you have to get ready for school and all these other things. Don't worry, guys, I'm going to run the live nonetheless. You can make sure that you go to my bio, go to my link, the YouTube link, guys. You need to go to the link, copy the link, paste it on your Google search engine, and then make sure that you subscribe to my YouTube channel, hit the notification bell, and then make sure that you are able to go and watch the video when I upload it after this session or later on when you come back from writing your paper, so that you can be on par with what we are doing, right? Okay, so that is just a little bit of what is in the content of the GEC paper. Moving right along, you guys need to know algebraic expressions, how to interpret algebraic language, like terms, unlike terms, adding and subtracting expressions, identifying, using the laws of distributive, associative, squares, cubes, square roots, determining the products between binomials and a binomial, factorizing, guys, solving equations, algebraic equations. You need to know all of that. Then you need to know your functions, you know, flow diagrams, your tables, interpreting linear graphs, how to sketch a linear graph, straight line graph, how to find the equation, and all types of questions related to functions. So this is in summary what the GEC paper contains or will entail, right? So to get us started, and guys, let us look at the GEC paper. Obviously, that has been questions that have been written in the GEC paper in the past. So if we look at section A, guys, this is a familiar question, and I'm sure many of you that have been practicing your papers have now been able to come across the GEC 2024 and 2023 paper. So this is the GEC 2024. Question 1, look at it, guys, very straightforward. So what is important when you answer GEC on Thursday? Please do the following. Make sure that you will be given an answer book, all right? The official GEC answer book. You will also be given the question paper, which will come in the form of a booklet. So you'll have a booklet, which is basically your question paper, and then you'll have another booklet, which is your answer book. That's where you will basically be writing the letters that you choose for your multiple choice. Ask and make sure that when they hand out those booklets and they hand out the question paper, make sure you get an extra additional paper for rough work. All right, your teacher must provide you with extra additional paper for rough work, because in order to select the correct answer in some of the questions, you're going to have to do rough work on the side. Then you'll be able to go and write down the correct selection. So please, guys, make sure you get a rough piece of paper. In fact, a large amount of a rough piece of paper, so that you can be able to write the rough work and then go and select the right answer. So section A, you can see there which number is undefined. A, is it 0/8? B, is it square root of 8? C, is it the cube root of -8? Or D, is it 8/0? So which one is it, guys? Which number is undefined according to that question there in section A? Which number is undefined? 0/8? Is it A? Is it B, square root of 8? C, cube root of -8? Or D, 8/0? So Swagtando in the comment section is saying it is D. Okay, Creative, I don't know what you mean by that 0, but I don't know. creative saying also D. Okay, we have only 2 people that have answered and have said it is D. So guys, undefined, what is that? So in the number system, right, we know that there are undefined numbers. All right, Fumanilo is saying the cube root of -8. So let us look at this, guys, very quickly. If we look at A, which is 0/8, guys, 0/8 is equal to 0, right? And here 0 we know is 1. We know that 0 is a whole number. 0 is also a natural number. By whole number we mean that number, those are numbers that start at 1 and they increase by 1 all the way to infinity. Those are whole numbers. Natural numbers are numbers that start at 1. They increase by 1 all the way to infinity. Okay, so 0/8 qualifies as a whole number. 0/8 also qualifies as a real number, because real numbers are all the numbers in our number system. Okay, then non-real numbers. Non-real numbers, guys, are all numbers that have a even root. Okay, so for instance, the square root of a negative number. Okay, what do we mean by even root? Even root, guys, means that the root itself. Okay, so if we talk about n, this would be an even number there. So for instance, the square root is having a 2 there. We don't usually write that 2, but that is what we call an even root. So it is non-real whenever we have a negative number underneath a even what? Even root. We call it non-real. In our calculator, we usually see maths error whenever we put these numbers inside the calculator. This is non-real. Then we have what we call irrational numbers. Okay, irrational numbers in summary are simply non-terminating numbers and non-recurring decimals. So whenever I'm given a irrational number, I usually put it in the calculator and I check. Non-terminating means my decimal does not stop. The numbers go on forever after the comma. Non-recurring means there is no repetition, no repeating. There's no repeating of numbers after the comma. Okay, so non-terminating and non-recurring is what we refer to as irrational numbers. Okay, so for example, the square root of 2, if you put it in the calculator, you're going to see it's actually a what? An irrational number. Why? Because if you press SD in your calculator after putting in the square root of 2, you are going to see that the number is basically going to be not stopping, meaning it's non-terminating, and also non-recurring. In other words, there is no pattern of repetition in the decimals. All right, so that's why we say irrational numbers are non-terminating and non-recurring. Then we have rational numbers. Guys, rational numbers include whole numbers, natural numbers. Okay, they include whole numbers and natural numbers. Oh, and let's not forget, there are also integer values. Integers. Guys, what about integers? Integers are numbers that basically have the 0 in there. They increase by 1. In other words, from 0 we're increasing by 1. 1, 2, 3, 0. But also we include negative numbers. Okay, from negative infinity to positive infinity, all the numbers where we are increasing and decreasing by 1, we call those integers. Okay, those are integers. All right, so we have whole numbers, start at 0, increase by 1, all the way to infinity. Natural numbers, start at 1, increase by 1, all the way to infinity. Real numbers, These are all the numbers in our number system. That includes irrational, rational, whole numbers, natural numbers, integers. Those are all real numbers. Then we say non-real. When we say non-real, guys, we are talking about numbers that underneath a even number root, there are negative numbers underneath the even number root, and when we put them in the calculator, we can see we get this thing, maths error. That maths error means the number is non-real, but only when it has to do with a negative number underneath a even root. That's what we mean by non-real. Then there's rational. Rational numbers, guys, are simply numbers that can be written in the form of a fraction, where the numerator and the denominator are both what? Integers. When you look at the decimals of rational numbers, the decimal numbers of rational numbers, 1, they are terminating. For instance, 6/10 is terminating because 6/10 can be written as 0.6. What do we mean by terminating? The number comes to a stop. It's a round off of a number. So for instance, we have rounded off here to 1 decimal place. If you round off to 2 decimal place, 3 decimal place, 4 decimal place, or any other decimal place, we refer to these numbers 1.583. Third decimal place, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th decimal place. Those are all terminating decimals because the decimal eventually comes to a stop. That's terminating. Or the other type of decimal number you get for rational numbers is recurring decimal. What do we mean by that, recurring decimal? We mean that the number, for instance, 0.5 with the dot at the top, it means that the 5 repeats. 1.35 dot for 35, it means that the 35 repeats. 35, 35, 35, 35. Okay, so for instance, if you were to put into the calculator this fraction, which is a rational number because the numerator and the denominator are integers, if you put this in the calculator, you're going to see that it actually is, when you press ST, you will find that this actually becomes a recurring decimal. So these are what we call rational numbers, my beloved grade 9s. So for those who are writing GEC, guys, these are important things you need to know, the number system. Why do you need to know the number system? Because questions such as the one that I just asked get asked. Then we have a category of numbers that we call undefined. What are undefined numbers? These are all the numbers that basically have what? Have 0 in the denominator, or you say a number divided by 0. Remember, this line is a division line. So if we say 5 divided by 0, or we say 6 divided by 0, we say that that number is undefined. You will find that you will get in your calculator, when you put these numbers, maths error as well. But please, guys, this maths error for division by 0 means undefined. Okay, whereas this maths error for numbers underneath a even square root, this maths error does not mean undefined. This particular maths error means what? It means non-real. So we must differentiate between the maths error for negative numbers underneath a even root, because that means non-real, and this maths error that you get here in your calculator for numbers divided by 0. That means undefined. So now let's go back to our multiple choice question. Hopefully that helps us a lot. Right, that helps us a lot because, guys, in order to be confident in answering GEC questions. So if you look at the question again, number 1, which number is undefined? Guys, is it 0/8? No, it's not. B, is it the square root of 8? No, it is not. All right. In fact, if you put the square root of 8 in your calculator, I'm sure you can see that the square root of 8 will give you an irrational number. 0 over 8 will give us 0, which means 0 is a natural number. I mean, it's a whole number, it's a real number, it's a rational number. The cube root of negative 8, that gives us negative 2. Negative 2 is a what? It's an integer, it's a real number, it's a rational number. Whereas D, 8 over 0, guys, that's what we mean. We just explained this, that any number divided by 0, 0 is in the denominator, or the number followed by division by 0, we know that is undefined. So it's definitely D. Okay, D is the answer. I hope you understand that. Check this out. Guys, GEC is meant to be easy. Let's come here now. Right, 2023, section A, number 1. Look at this, guys. Once again, we are being asked a question on what? On numbers. 2023, from 2024 to 2023, look at what they're doing for section A, number 1. Which word describes negative square root of 3? Is it A, rational, B, irrational, C, undefined, D, non-real? Which one is it, guys? Which word, number 1, best describes negative, then square root of 3? Is it A, rational, B, irrational, C, undefined, or D, non-real? Which one? Which word best describes? Okay, Mastola says B. Okay. Mastola says B. Manlindengosi says C. Swagtando says D. Okay. And guys, only one of you is right, and the honest answer is that only Mastole and Mr. How can you call yourself that? Okay. So if we look at what we had said earlier on, negative. See, the negative sign is just on the outside. You put this in your calculator, you are going to get a non-terminating, non-recurring decimal. Okay. No, not you, D1. Someone else has a name that is very, very rude there. It starts with F. Okay, non-terminating and non-recurring. Okay, you'll get a non-terminating and non-recurring. So this here, guys, is a typical what? It's an irrational number. Remember, the negative sign is outside the square root. It's not, if it was a negative, if the negative number was inside the square root, we'd say this is a non-real number, but this negative sign is outside. You put the negative, the square root of 3 gives you a non-terminating and non-recurring decimal. And what did we say, guys? It's an irrational number if it's non-recurring and non-terminating. So in other words, which word best describes negative square root of 3? It is B, irrational. Irrational. That's what best describes the square root, the negative square root of 3. Okay. Right, so you see both questions, right? Okay, now let's go to number 2 now. Number 2, given 12, 18, and 27, what is the LCM of the numbers? Given what? 12, 18, 27. What is the LCM of the numbers? Okay. Now I see what our friend is saying there. You guy, I don't know why GDS, your name, your TikTok name is just ridiculous. So I'm not going to call your name because your name is just derogatory. You need to come up with actually a better name. This is, I mean, really and truly, even if you want to be a TikTok, you want to be anonymous, and you don't want to actually, but the name that you have there is just insane. Okay, call you Tyrone. That name. So anyways, given 12, 18, and 27, what is the LCM of the number? Now, LCM, what do we mean by that? We mean lowest common multiple. All right. So I see what you've written there, that you're saying it's B. But guys, how do we find the LCM? Hopefully, we know that we can take all of these numbers and find the product of their prime factors. So if we take 12 and we say equal to shift fact, we don't even need to use the letter method here, guys. Okay. Okay. So if we press 12 is equal to shift fact, what we do get is we get 2 squared times 3. All right. That is basically the product of prime factors for 12. If we take 18, we go to our calculator and press shift, then fact. Okay, we get what? We get basically the 3 squared times 2. And then if we take 27 and we do the same thing, 27 is equal to shift fact. What are we trying to do here? We're trying to avoid using the ladder method because it's going to waste time. We don't want to waste time in GEC. What we want to do is we want to take the rough paper and on the side do this calculation so that when we do our selection, we do the right selection. In the answer book, we can write in the correct letter. So what we do on the side, this is rough work on the side because we don't want to select the wrong answer. 27. If you say 27 is equal to shift fact in your calculator, you are going to get 3 to the power 3. Grade 9s. Okay, so now from here, what is the LCM? Okay, now we are going to choose the common base with highest exponent. All right, the common base with highest exponent. Okay, starting with what is common for everything. Let's start there. So if we look at 12, 18, and 27, which base is common? Base 3 is here. Base 3 is there. Base 3 is there. Now, out of those common bases, which one has the highest exponent? Is it 3 to the power 1? Because we know there's a 1 there. Is it 3 to the power 2? Or is it 3 to the power 3? Which one has the highest exponent? It is obviously going to be 3 to the power 3. So we write that as part of our LCM. Okay. Then we're going to look at 2 as well. Base 2 is not common for all 3 of the numbers, but we are still going to look at it. All right. And since there are 2 bases of 2, we are going to look at the common base for these 2 that has the highest exponent. So which one, 2 or 2 to the power 2, which one has the highest exponent? It is obviously going to be 2 to the power 2. We write that, guys, as a product to 3 to the power 3 because that all of it is our LCM. So what I'm saying to you is that when you want to identify the LCM from numbers, you can first write down those numbers as a product of prime factors. Using your calculator, you just simply take the number, say equal to, say press shift, press fact, you write down the product. Same thing with 18, same thing with 27. These are the product of prime factors for each number. Then after that, to identify the LCM, you choose the common base with the highest exponent. All right, so 3 is common for all 3 numbers. So that's why from the 3 base, we choose the one that has the highest exponent, and it is this one. There it is. Then we look at the other base 2. Base 2 is not common for all 3 numbers, but it's common for these 2. So where the LCM is, we also look at the leftovers. Even if they are not bases that are common for all 3, we look at the leftovers and we check the common base with the highest exponent there as well. Then we write that as a product to what we had for the common base for all 3 numbers. So if you look now, we have 27 times what? Times 4. 27 times 4 is 108. So the LCM, guys, between 12, 18, and 27, we go back to our answer sheet. What is the LCM of the numbers 12, 18, and 27? Our answer there is B, guys. That's the answer. B is the answer. So you can go to the answer book now and write down B as your selection of the correct answer. I hope that makes sense. So that's how we find LCM of numbers. That was 2023. That was 2023. Let's go back to 2024. What is the highest common factor? Number 2. The highest common factor of 125, 200, and 510. What is the highest common factor between 125, 200, and 510? Number 3 goes on to say, what is the LCM? You see, guys, look at so paper 1 in 2023 and 2024, you can see the similarities. Okay, you can see this. So we need to know how to find LCM and HCF, guys, very clearly, please. Okay, now 125, 200, and 510. Okay, so the calculator is your friend here. Calculator will help you a lot. You go again, once again, this time round we're wanting the HCF, not the LCM. Same thing, we grab our calculator, we say 125 is equal to shift fact. Okay, so that we can find the product of prime factors. Okay, that gives us 125. So 125 is going to be what? 5 to the power 3. Do we agree that it's 5 to the power 3? Okay, hopefully we all agree it's 5 to the power 3. Then what about 200? What about 200, guys? What is the product of prime factors for 200? If we say 200 is equal to shift fact, what do we get? So no one is going to help me here. Okay, alright, let me just go ahead and take my own calculator and do it on my own then. So 200 plus 200 equal, then press shift, then press fact. There it is, guys. 2 to the power 3 times 5 squared. Then 510, we do the same thing. 510, we press equal, we press shift, we press fact. There it is. 510 is going to be 2 times 3 times 5 times 17. This time round we want the highest common factor. Now for the highest common factor, we are going to choose the common base with the lowest exponent this time round, not the highest exponent, but with the lowest exponent. But it has to be for all 3 common bases. It has to be for all 3 common bases. What do you press after shift? So once again, simply put, guys, what I do, fact, I just press fact. So 510, there we go, 510. There it is, né? I press equal. Then I press what? I press shift. Then I go press here, fact. You know, the reason why I press shift is so that I can select the yellow. So that's the button, fact. and there it is. Okay, so there it is, guys. Now I have my product of prime factors for each number. Since I want the highest common factor, this is paper 1, GEC. Since I want the highest common factor, what do I do, guys? I am going to choose the common base for all 3 common bases. Now this time round, I need to make sure that it is just only for common bases for all 3 numbers. I can't go down and choose for 2 and 1. No, just for the 3. Highest common factor demands that I choose the common base with the lowest exponent for all 3 common bases. So let's see. Here for 125, 500, and 510, what is common for all 3? 5, 5, 5 is common for all 3. There's nothing else that is common for all 3. So when we go and identify the highest common factor, we choose the common base, but with the highest exponent for all 3. So which one has the, no, not the highest, sorry, with the lowest exponent. Remember, for highest common factor, we don't choose the one that has the lowest exponent, the highest exponent. We choose the one that has the lowest exponent. So the common base with the lowest exponent. So is it 5 to the power 3? Is it 5 to the power 2? Is it 5? No, it is definitely 5, and it's 5 to the power 1, and that is it. There's nothing else, guys, that is common for all 3. Okay, so we can't multiply with anything else because 5 is the only common base that is common for all 3 numbers. So for highest common factor, we need to ensure that it's common for all 3. That's the first thing, and it must be the base that has the lowest exponent. That's how we identify highest common factor. So it is 5, and that is the answer. 2 is not common for all 3. 3 as the base is not common for all 3. 17 is just alone, so we don't even include that. So the highest common factor of 125, 200, and 510 is 5. Let's move on to the next question. Number 3. What is the LCM of 75, 450? So sorry, for number 3, guys, and for number 2, we would select what? We would select B as the answer. We would go and write in our answer book the letter B because we found the answer. You see, this is important, guys. Rough work on the side in the paper that you've asked for, and then you make sure, guys, those who are writing GEC, that you write your answer letter B in the answer book provided. You're going to see, guys, there's an answer book that you'll be provided. Okay, now 75, 450, and 1800. Now here we are being asked to find the LCM of 75, 450, and 1800. So we do the same thing. This time round, we want the LCM. And remember, what did we say about LCM? Here we want the common base with highest exponent. All right. So let's go first to our calculator and write down the product of prime factors. So what are we going to do? We are going to press 75. Then we are going to say equal. Then we are press shift. Then we are going to press fact. We get 3 times 5 squared. So 3 times 5 squared. Do the same thing with 450. 450 equal, press shift, then press fact. We get 2 times 3 squared times 5 squared. That's 450. And then lastly, 1800. We do the same thing. 1800. We press equal. We press shift. We press fact. We get 2 cubed times 3 squared times 5 squared. Okay. So here we are, guys. we have now the product of prime factors. Now, since yours doesn't have fact, then you need to get the one that has fact, my friend. There it is. There it is. Okay, your scientific calculator, guys, that you should be using is definitely the Casio calculator. Please, please, please. There it is. Okay, please. I beg you. I beg. You press shift. Remember, shift here, you press there, and then when you press shift, guys, fact is when you select shift, you are selecting all the yellow things there. All right. So that's why we press shift, so that we can have an opportunity to select the yellow thing there, which is fact. Fact is there. And then you should be able to get these product of prime factors. Now we are going to choose the common base with the highest exponent. Let's start first with the lowest common multiple. Remember, we start first with the common bases for all three. So 3 is common for all three. So what then do? We are going to write LCM and then write the common base with the what? Since it's the LCM, we go for the opposite, the one with the highest exponent. So that means which one? 3 squared, or 3? Obviously, 3 squared is the highest. Okay, we write that once. Then we go to our leftovers. Lowest common multiple means we also go for our leftovers. We go for the leftover bases. They are not common for all three. We call them leftovers because it's the lowest common multiple. L for leftovers. So let's go to the other bases that are not common for all 5 is also common for all 3. Sorry, guys. 5, 5, and 5. So what do we notice? Squared. So we just write 5 squared ones. Okay. Then we go to our leftovers. We can see 2 as a base is not common for all 3, but we still, for our leftovers, choose the common base with the highest exponent. So that's going to be times 2 to the power 3. Okay, so the product of all of this, okay, we chose the common base with the highest exponent. So that means we are going to take 9 multiplied by 25 multiplied by 8 and see what do we get. So if we go to our calculator, 9 times 25 times 8, what do I get from that? I get the answer 1,800. So that means that is my LCM. Okay, so LCM, yes, LCM, we choose the common base with the highest exponent. And remember, that common base we must first look at the common base that is common for all 3 numbers. That's the first thing. So for instance, 3 is common for all 3, but we choose the one that has the highest exponent, that is 3 squared. We just write it once. Then 5 as a base is common. 5 is common for all 3. So we choose the base, all right, with the highest exponent. Then after that, base 2 is not common for all 3, but those are the what? The leftover bases. So the leftover bases, if they are common, we choose the one that has the highest exponent as well, and we multiply it there as well. And then after that, we write the product. 9, which is 3 squared, times 25 times 8 gives us 1,800. That is basically the lowest common multiple. That's what we do for LCM. What we do for HCF is different, because for HCF, guys, all we are interested in is choosing the common base for all 3 only. We look for the common base for all 3 numbers, or all 2 numbers, however many numbers we are asked to find the highest common factor for. But from there, we choose the common base with the lowest exponent. So for instance, here we saw that 5 is common for all 3, but which one has the lowest exponent? It is 5. So we write 5 there. Then we can see base 2 is common for these 2 only, but for highest common factor, we do not go for common bases for 2 numbers or for 1 number. We only go for the common base with the lowest exponent for all 3 numbers, and that's it. Okay, Ms. D asked earlier on, may you please repeat what is the function of fact in calculators? Guys, you see all these yellow things, this yellow thing here, that yellow thing there, that yellow thing there, that yellow thing there, that yellow thing there, that yellow thing there. If I want to select all of these yellow things that you see there on my calculator, then it's important that I first press shift. Okay. Now see here, for instance, if I was to press here, right, then I'm going to get that cube root. Look at it. If I press, look, you see, I get the cube root. But without selecting shift, then I press there, I only get the square root. So the role of shift in your calculator is so that you can select all these yellow things that you see on your calculator. The role of alpha in your calculator is to select all the red things that you see in your calculator. I hope you understand now. That is the role of shift. Okay, so guys, let's go now and check the answer. What is the LCM of 75, 450, and 1800? Number 3, guys, it is 1800. It's A. That's what we would select as our answer. And we have the evidence of our working out to support why we actually did what? Selected that answer. So rough work on the side, guys. Rough work on the side. Okay, let's move on. Just wanna turn over to the other question paper. Look at this one. Number 3. What is the HCF of the numbers 2/3, 2/6, 1/6, and 4/3? So there we have a fraction. And they're asking us what is the HCF of 8/30 and 12/36. So this one, what's nice about it is we can look at the numerator, all right, and then look at the denominator, all right. So we have 8 and 12 in the numerator, and we have 30 and 36 in the denominator, all right. So if we look at those, I'm sure, guys, we can find the product of prime factors for 8, and we can find the product of prime factors for what? For 12, right? So if we take 8 and we say 8 is equal to shift fact, we get 2 to the power 3, don't we? Okay. I hope we see that. If we take 8 and 12, right? 8 gives us 2 to the power 3. That is the product of prime factors. If we say 8 is equal to shift fact. For 12, if we say 12 is equal to shift fact, what do we get? We get 2 squared times 3. Okay. Then if we go to the denominator, 30 and 36, I'm sure you can see as well, 30 and 36. You press 30, say equal, press shift, press fact. What do you get? We are at number 3 of this question. What is the HCF of the numbers? 8/30. Yeah, very good. 2 times 3 times 5 is what we get for 30. Then if we do the same thing with 36, 36 is equal to shift fact. What do we get there? Yeah, so we get 3 squared times 2 squared, all right? Yeah. Now, from the numerator, we can find the HCF, okay? From the numerator, we can find the HCF. then from the denominator, we can also find the HCF. Remember, what did we say about HCF? We choose the common base with the what? With the lowest exponent for all two numbers. Remember, we had here 8, we have 12. Okay, 8 is 2 to the power 3, 12 is 2 squared times 3. So if we actually get the answer that we should get in the numerator there for our highest common factor in the numerator, the common base with the lowest exponent is actually 2 squared, which is actually 4. Okay, if we go to the denominator, 2 times 3 times 5 with 3 squared times 2, we go for the common base. Okay, we go for the common base with the what? With the lowest exponent. So it's only 2 and what? And 3 that is common. So base 2, we are going to say 2 what? 2 times 3 squared and 3, we go for 3. That gives us 6. So in other words, what do we now get? 4/6. That is our fraction highest common factor. The 4 in the numerator, the 6 for the denominator. But this can be simplified, guys. 4/6. That gives us 2/3. So once again, what did I do here? I went to the numerator. The numerator values were 8 and 12. I wrote the product of the prime factors. Alright? And then what did I do after that? I actually went ahead and chose the base, the common base with the lowest exponent. So 2 is the only one that is common. Then I chose the common base with the lowest exponent. It's 2 squared, not 2 to the power 3, which is 4. Then we go to the denominator. In the denominator, we have the number 30 and 36. So we found the product of prime factors for 30. It's 2 times 3 times 5. For 36, it's 3 squared times 2 squared. Then we choose the common base with the lowest exponent. Which one is it? 2 and 2 are common bases for both numbers. So we are going to have to choose the one that has the lowest exponent. It is this one. Then 3 and 3 are also common bases for both numbers. So I choose the common base with the lowest exponent. I multiply it to the 2. 5 is not a common base. Alright? So basically for highest common factor, we do not include leftovers. We don't. So 2 times 3 is 6. Then as a fraction, it would be 4/6. But 4/6, when simplified, is actually equal to 2/3. So here, guys, is the answer. It's 2/3. So when I go and select the option for number 3, it is A. I've selected an option that is available and that I have been able to, in my rough work out and get the answer. Okay, guys, in the GEC paper, there's enough time for you to do your rough work. So please make it a point that you do rough work where there is a need. Some questions you will look at and be like, the answer you can see, that's fine. When you know answers from your knowledge, that's fine. Okay, but when you don't, please make it a point that you actually do what? You do working out on the side. Guys, if you're writing English, that's fine. If you can't really join the live because you are preparing to go to school, you're writing English, your mind is not in maths, that's fine. Remember, I upload all of these videos on my YouTube channel. The link is in the bio. The YouTube link is in the bio. Go and copy the link for the YouTube. It's also called Maths is a Game. Copy the link for the YouTube channel, paste it on the Google search engine. Press search and then find my YouTube channel. Then subscribe. Hit the notification bell. Then after doing that, when I upload this video later on, you will be able to rewatch it at your own time. Okay? Yeah, right. So I hope that makes sense. Yes, renuma, it is irrational, the first one. Okay, and then the second one, the LCM of the numbers, we actually worked it out. It's B, it's 108. And then for number 3, we just worked that one out. A is 2/3. That's the answer. Okay. Let's come back here. Moving between 2024 and 2023. Look at number 4 now. We are at number 4 now. Okay. We have time. We have a table there. We have time 12, 9, 8, 6. Then in the next column we have average. Next row we have average speed 60, 80, 90, 120. Okay. Okay, Mascole. Enjoy school. Which time are you going to be on? It's my time to school. Guys, I probably will do another live session later on tonight, most probably, but at 9 p.m. Okay, maybe at 9 p.m. tonight I may do a second session. Not necessarily repeat this one. I'm going to do another session where I continue. Okay, those who missed this, go to my YouTube channel, guys. The link is in my bio. Make sure you watch when I upload this one. So what is the relationship? Number 4 is saying, what is the relationship of average speed to time in the table? Guys, what is the relationship of average speed to time in the table? Now, A says rate. Is it rate? Okay. B, is it ratio? C, is it indirect proportion? Or D, is it direct proportion? Now, those who know what they know will know that the answer is actually C. The answer is C, not D, not B, and not A. Okay, and William in the comment section is telling us why we say the answer is actually C. If you look at time, 12, 9, 8, 6, what's happening to our values there? That quantity of time is decreasing. Look at average speed, 60, 80, 90, 120. What's happening there? That quantity is increasing. So as William says, while one quantity, which is time, decreases, what's happening to average speed? Average speed is increasing. So in our table, the relationship that is represented there is one of indirect proportion, because indirect proportion is the comparison of two quantities, okay, where one quantity increases. As one quantity increases, the other one decreases, or vice versa. Okay, so that's why we select C. Why can't we say it's D? Because, guys, D, direct proportion, the definition of direct proportion is it's the comparison of two quantities, and as one quantity increases, the other one increases, or as one quantity decreases, the other one decreases. So that's why we say number 4 cannot be D. Why can't we say it's B? Guys, ratio. Ratio is the comparison of two quantities of the same type. Time and average speed are not the same type. They have different units. So time and speed are not the same type. So we can't say it's ratio. And then lastly, is it rate? No, we cannot say it is rate. Okay, because though we are comparing here two quantities that are different, but more specifically, that relationship we see of average speed to time in the table is a relationship that speaks of C, indirect proportion. So we say the answer is C. Guys, you see how important it is for you to know, these things. When you do, then you're going to have ease in answering this question. So please make sure that you understand the topic, rate, ratio, direct and indirect proportion, so that when you see questions you can answer. So number 4 can be answered without any working out. You see, so that's why I'm saying some questions you'll read them, you'll be able to see the answer from just looking and recalling the knowledge that you have learned. Some questions will require you to do rough work on the side before selecting an option. So number 4 is simple. We just select the option. It's number 4. Number 4 what? 4C. Indirect proportion. As one quantity is decreasing time, the other one is increasing average speed. Okay. Let's move on to the next question. Okay. The question about Tato. Okay. We are learning there about Tato. Tato. What's happening with Tato? We are told that Tuto runs 6 kilometers. Imake William, what is no? Why are you saying no? No for what? William, you are saying no. Okay, I don't understand why William says no. Okay, so number 5 is Tuto, right? Tuto runs, to lady. Tuto, what did lady say? No, Lady K, it's not direct, it's indirect, please. Yeah, it's indirect. When one quantity increases and the other one decreases, then we say it's indirect. Okay, but when they both do the same thing, as one quantity increases, the other one increases, we say it's direct. Or if we say as one quantity decreases, the other one decreases, we say it's direct. Okay, let's not confuse the two. Number 5, Tuto runs 6 kilometers in 24 minutes. How long will it take him to run 10 kilometers at a constant speed? Okay. Now, whenever we look at this, you can clearly see that we are looking at Tuto. So we need to do a calculation on the side here. Tuto is running what? 6 kilometers in what? 24 minutes. This is important. Then they are asking how long will it take to run 10 Ks? Okay, at the same speed, because if they're saying constant speed, it means at the same speed. All right? Yeah, so I hope that makes sense. Now, guys, there's 2 ways of looking at this question, depending on who you are. Okay, some people will look at this and be like, okay, I can see that there's distance here as a quantity, right? And there's time, right? So some people can tabulate this thing, right? I'm going to answer this thing in 2 ways so that you guys can appreciate how we can answer this question. Now here, in our options, we can see that the answer is in hours. So we need to convert minutes to hours. That's the first thing, because remember, kilometers, we have kilometers per hour when it comes to speed. So these minutes need to be converted. How many minutes are there in 1 hour, guys? Because we need to first convert. We must work with units that agree with one another. So my question is, how many minutes are there in 1 hour? Okay, we know there are 60 minutes. So what we are going to do is we're going to take 24 and divide it by 60 so that we can get, guys, the hours that they are in 24 minutes. Okay, yes, William. So 24 we get 2/5. Okay, right, so I'm just going to write 2/5 hours. I know what it is in decimals, but I'm just going to maintain it as a fraction. It's no problem. Sorry about that. So Tuto runs 6 kilometers. This is the distance that he runs. In how long? In 24 minutes. That means 2/5 hours. The question that is being asked is the question that was being asked was, how long will it take? So they want the time that it will take for 2 to run 10 kilometers. So I can write 10 kilometers here, and then I know I have a question mark as to how much time it takes. And we were told that at that same constant speed means that the speed does not change, because they are saying at a constant speed. So I said I'm going to answer this in 2 ways. The first way would be to, like I said, represent this in a table, and then from that you can check what is happening with this quantity. If it takes 2/5 hours for 2 to run 6 kilometers, what are you expecting 2 to run? How much time are you expecting 2 to run 10 kilometers? Are you expecting 2 to run more than this amount of hours for 10 kilometers? Are you expecting him to run less than 2/5 hours? If Tuto is running 10 kilometers and he's running at the same speed, at the same constant speed, are you expecting Tuto to run more than 2/5 hours, or are you expecting him to run less than 2/5 hours? Let's start there. What are you expecting? Are you expecting Tuto to run more than this amount of hours, or are you expecting him to run less than this amount of hours if he's running 10 kilometers? So Mochal says we're expecting him to run more. So guys, what are you seeing here? You are seeing that with distance, as you increase the distance, you are expecting that you are going to also what? Increase the time, because you are expecting Tuto to run more hours. All right. So as we increase distance, we are increasing time. This is a typical situation of direct proportion. And we know that with direct proportion, the ratio between quantities is the same, or we say it is constant. Okay. So guys, as distance increases, you are expecting, like as I said to you, what are you expecting will happen with Tuto as he runs a greater distance? You are expecting him to take more hours. If in 6 kilometers it took him 2/5 hours, you are expecting him to run 10 kilometers in more hours. So that means as distance increases, the time should also increase. This is a typical example of what? Of direct proportion. That means what? We know that for direct proportion, the ratio between the quantities is the same. What do I mean by that? Simply put, guys, this is what I mean. I want the time. I'm going to let X be the time that I need to see how long it will take Tuto to run what? 10 kilometers. So I'm going to let that be X there. Then I'm going to say X start from the bottom over 10. Why am I saying X over 10? Remember, I said for direct proportion, what is constant? The ratio. The word ratio leads me to the word rational. Ratio, rational. What does rational mean? It means fraction. So what I know, guys, is that the X over 10, the ratio between, this is between quantities, time and distance, the ratio between the quantities, so X over 10 should be what? The ratio between the quantities should be the same, constant, which means X over 10 is equal to what? 2/5/6. Now maybe writing this as a decimal will help me, all right? Because 24 divided by 60 is 0.4. So we can say X over 10 is equal to 0.4/6. then I can solve for what? For x. I can solve for x. All right, guys, as I said, remember we learned that Tuto runs 6 kilometers in 2/5 hours. Now we are being asked, how long will it take for Tuto to run 10 kilometers? So I said we can write this in a table with two quantities, distance and time. We can see that distance increases. What are we expecting with Tuto as far as the time? When Tuto runs 10 kilometers, are we expecting him to run less than this number of hours or more? We are expecting him to run more. So that means as distance increases, we are expecting time to increase. That means this is a direct proportion situation. That means the ratio between the quantities, because this is what direct proportion states in definition, that as one quantity increases, the other one increases, or as one quantity decreases, the other one decreases. What do we know then about that? That the ratio between the quantities, this is a very important detail, that for direct proportion, we always know that the ratio between the quantities is what? Is constant. Therefore, we can take this x and write it in the numerator and say x over 10. That's a ratio, it's a fraction, because ratio means rational and rational means fraction. So we can say x over 10, move in the same direction, is equal to what? 2/5/6. But remember, 2/5 can be written as 0.4. Then all we do here, guys, when x, and the reason why I wrote x over that is because I want the x to be in the numerator. It makes it easy for me. So please move in the same direction. If you say x, then this is over 10. Then you start at the bottom for the other fraction, 2/5/6. Remember, 2/5 can be written as 0.4. Then it's easy from here. You just cross multiply. X is equal to 0.4 times 6 over, 0.4 times the 10. You are cross multiplying, divided by 6. You take your calculator, you say 0.4 times 10. 0.4, we multiply by 10, okay? And then after that, we divide by 6. Divide by 6. What do we get? 2/3. That is the answer. We get x is equal to 2/3. So it's 2/3 what? Hours. So when we go then to our multiple choice options, okay, let me just go and look at that. Number 5, Tuto runs 6 kilometers in 24 minutes. How long will it take him to run 10 kilometers at a constant speed? Is it A, 1/4, B, 2/5, C, 2/3, D, 5/2? Guys, you can see that the answer is there. But you see, I did calculations on the side. I can't just assume. So I said, guys, that is one way of doing this question. I want to show you the other way. I want to show you the other way of doing the same question. The other way, guys, would have been to basically calculate first. Remember, D is equal to 6 kilometers. This is distance. This is time. The time, remember I said we need to convert to hours. We get 2/5 hours, which we know is 0.4. So whether you write it as a decimal number, which is rational, or a fraction, which is also rational, remember this is a terminating decimal, that's fine. Then what we are going to do, we are going to calculate the speed. All right? We are going to calculate the what? The speed. And guys, by now we should know this triangle. DST. DST. D, distance. S, speed. T, time. We should know this triangle. Whenever we want to calculate distance, we say speed times time. If we want to calculate speed, we say distance over time. When we want to calculate time, we say distance over speed. So what do we want here? We want speed. Okay? Okay, remember guys, YouTube channel, you can watch this later on when you come back, for those who yeah. So distance, so S is equal to D over T. D means 6, T 0.4. Answer 6 divided by 0.4. Calculator, 6 divided by 0.4 gives us 15. So that's the speed, 15 kilometers per hour. But remember, we are not looking for speed. This helps us to know that, oh, okay, Tuto is running at this speed. He's running at this speed all the time. But now we are being asked, how long will it take for him to run 10 kilometers? So at this speed, which is 15 kilometers per hour, running now a distance of what? 10 kilometers. How long does Tuto take to run? All right, so therefore we want time now. Remember, time is going to be what? Distance over speed. So we say T is equal to D over S, and then we substitute. D is 10, S is 15. Calculator, 10 divided by 15. If we don't know, 10 divided by 15. Simplification would be straightforward. We should be able to see that actually from our calculator. What is 10 divided by 15? We get, there it is again, 2 over 3 hours. Okay, do you see that again, guys? It's coming up 2 over 3, which is not 0.6666666. Okay, it's a recurring decimal, that one. Rational. So that's why we say rational numbers are fractions. They can be written in decimal numbers as recurring decimals. That's a typical example. So guys, you have 2 ways of answering this question, okay, depending on who you are. All right, okay, let's move on. I will be, don't worry. Okay, can you do please one more last time? This one. Which one? This one. Okay, remember I said Tuto runs 6 kilometers in 24 minutes. And then they are asking us, how long will it take? What's the time? How long will it take for Tuto to run 10 kilometers if they are running at a constant speed? Guys, when they are saying constant speed, it means Tuto, for the 6 kilometer race, he will run at that speed. For the 10 kilometer race, he will run at the same speed. That's what we mean by constant speed. I hope that makes sense. So therefore, what we are going to do is we are going to use DST, this triangle DST, and calculate first what is that speed that Tuto is running at. So distance is 6 kilometers. We collect that information. Time needs to be converted from minutes to hours, because remember, kilometers resonates with hours. Okay, thank you Ghostface for the rose, I really appreciate it. So say 24 divided by 60, you get 2 over 5. That's 2 over 5 hours, which is 0.4 hours. I hope we are together there. Then speed, you want speed. Why? Because you are going to use that speed together with this distance so that you can calculate the time that Tuto takes to run 10 kilometers. Okay, so we first calculate the speed, and we do that simply by using this triangle here, which is DST. What do we want? Speed. And I said to you, if you hide S, when you want to calculate speed, it means you say distance divided by time, right? If you want to calculate time, you say distance divided by speed. If you want to calculate distance, you would say S is next to T, so we multiply S, which is speed, times the time. Okay, so here we are, D over T. D is 6, T is 0.4. You get 15 kilometers per hour as your speed. Then you take that speed, you go and calculate time. Speed is 15 kilometers per hour, distance is 10 kilometers, time is what you are looking for. So therefore you're going to say T is equal to D over S. What's D? 10 kilometers. What's S? 15 kilometers per hour. Then time, you calculate it, you get 2 over 3 hours. You go to your options there. It is C. Okay, that is the selection that you are supposed to have made for number 5. Calculation done on the side, and then the selection made on your answer book. So you write C as your answer. You're welcome, Loki Junior. You're very welcome. Let's move on to the next question. GEC, guys, look at this, number 6. Dibolelo shares. Dibolelo bought shares. Hopefully one day you guys will also buy shares, okay, at a reputable company. Dibolelo bought shares for 5,300 at the beginning of March 2006. So imagine, beginning of March, this guy goes ahead and he buys what? Shares. For how much? For 5,300. Important information. She then sold the shares when? At the end of what? Of February 2023. And how much did he receive, guys? He received 11,000, guys, 11,291 rand 45 cents. This guy doesn't mess around. Okay, look at how much he bought the shares for, and look at how much she then sold the shares. All right, you look at the number of years that passed between March 2006 to the end of February. So you need to think about that. The beginning of March 2006. So that means the beginning of March 2006, all right, all the way to February, end of the year 2023. All right. All right. Remember, guys, the end of February is sort of like the beginning of March, if you think about it. No. Yeah. The end of February is like the beginning of March. So you could literally then count 2023. Okay. From 2023 all the way, guys. How many years is that? All right. So like I said, the beginning of March, all right, 2006 to the end of February. Guys, the end of February, like I said, is like the beginning of March. It's similar to the beginning of March, right? So the question is, how many years did our good friend here? How many years? All right. So 2023. Okay, William is saying 16 years. Marlo, you can watch it in my YouTube channel. Those people who are saying, please do it after school in the afternoon and all of that stuff, what you have missed, you'll be able to watch on my YouTube channel. I will be uploading this onto the YouTube channel, because when I continue, I am not going to go and start back where I left off, all right? Yeah, I'm not going to start back where I left off. Okay, I hope that makes sense. Yeah. So what's nice here, all right, is in actual fact, this is not going to be 16 years. All right. It is not going to be 16 years. It is going to be 17 years for those that actually are very much aware. All right. Okay. 17. Yeah. 17. All right. So that's where I think most learners go wrong here. Okay, because you need to actually now imagine the number of years, you know. So what we can do there is we can say, yeah, we can take that 2023, we minus the 2006, and then yeah, we can see the number of years is actually what? Is 17, right? Yeah, I hope that makes sense to you guys. Hope it makes sense. So 17 years there we have, ne? Yeah. Then we are asked, what was the compound interest rate per annum? So from the information we've collected, N is 17, compound interest. Now, remember, guys, when we talk about compound interest, we are talking about interest on interest. And there's a formula attached to calculations that involve compound interest, and it is this one. We know most there's a twin interest that we also should know besides compound interest, and that is simple interest. Its formula slightly different from the one that is compound. Is A is equal to P brackets 1 plus I times N. So compound interest, interest on interest. Interest on interest. Compound interest is interest on interest. The growth for compound interest is exponential, whereas the growth for simple is constant. Okay, constant. Exponential, constant. Okay, that's why, for instance, we have this exponent n and then linear, right? You know, just like a straight line graph, that's linear growth. Okay, yeah. So if you want to invest something, it's always sweet to actually invest, obviously, using compound interest. And most banks obviously subscribe to this type of compound interest, you know. So let's go back to the question though. Dibolelo bought shares for 5,300 at the beginning of March. So that means the principal amount was 5,300. Okay. The amount that Dibolelo bought the shares. Then she sold the shares at the end of February 2023 and received 11,000. So Dibolelo received, meaning the final amount, the amount after 17 years was 11,291 rand 45. And then I is what we need. I is what we need. They are asking us in the question, what was the compound interest rate? The compound interest rate, small I. Okay. The compound interest rate. Guys, please take note. Go read the question again. Dibolelo bought shares for 5,300 at the beginning of March 2006. She sold the shares at the end of February 2023 and received what? 11,291 rand 45 cents. The question is, what was the compound interest? People, we are being asked what was the compound interest rate. They didn't ask us what was the simple interest rate. They asked us what was the compound interest rate. So that means in this formula, we need to identify from our situation or scenario what A is, what P is, what N is, so that we can calculate the compound interest rate. They want I, all right, and they want that value of the compound interest rate as a percentage, as you can see from your options. So I'm coming back here. N is 17 years. P is 5,300. A, 11,291 rand 45 cents. I, we don't basically have. That's what we want. Then we go to our formula. A is equal to P, since we are dealing with compound interest. P is 5,300. The amount at the beginning. P is what we call the principal amount, the amount at the beginning, 5,300. 1 plus I is what we want. N is what we basically got. And then A is 11,291 rand 45 cents. Now what I need to do is I need to find the value of I. In other words, make I the subject of the formula. So you can see here currently 5,300 is outside this bracket. So what we are going to first do, we are going to first do what? Divide both sides by 5,300. I usually say to my learners, the dad is at the door. We need to get rid of the dad. What we want is we want the child inside the home. So the first thing we need to do is we need to get rid of the dad. The dad is blocking the door to the house, but the dad is multiplied because the dad has a relationship with the bracket of multiplication. Brackets mean multiply. So we first need to get rid of the dad. How do we do that? We divide both sides. What we do on the left, we do on the right. We divide both sides by 5,300. Okay? A lot of people are writing English today. Then what happens? That cancels. Then we are left with 1 plus I to the power what? 17. This side we are left with that 11,291 rand 45 cents over 5,300. So I would retain that for now. Okay, I'm going somewhere. Don't use your calculator and calculate this yet. Just keep it at this. Okay. Then 1 plus I to the power 17. This exponent is the surveillance camera to the home. Remember, we want this boy, we want this person isolated alone. The surveillance camera needs to be taken off. How do we take off the surveillance camera? We take the 17th root on both sides. We take the what? The 17th root. This, to get rid of this to the power 17, we take the 17th root. But remember, what we do on the left, we do where? On the right. We take the 17th root of this as well. Okay? The surveillance camera needs to go. This is an exponent. So if we want to get rid of this exponent, remember we want I, guys. We want to get rid of this exponent. We take the 17th root of this entire thing. Why? So that can disappear. The surveillance camera can go. Guys, we always get rid of the surveillance camera by taking the root of whatever the surveillance is. So if it is 17, we take the 17th root. If it was 3, we would take the 3rd root. If it was 5, we take the 5th root. If it was 8 that was there, we would take the 8th root. What does that do? It makes me be able to get rid of the exponent. Now, guys, look at what I have. 1 plus I. That is gone. But please still maintain what you have there on the right. Now the last thing that is left now, I is nearly alone. This 1 needs to go. I take the 1 over to the left. I transpose it, in other words. I do what? I transpose it. So what happens? The 1 goes over. It is negative 1. That's equal to I. I is now alone. Did you see how I got rid of everything that was surrounding I? It started here. Daddy was blocking the door. Let's imagine a son trying to go on wants to get to know the daughter of the house, but there's all these obstacles. There's the 5,300, which is the dad. There's the surveillance camera. It's watching what you are doing as you want to come to the home. There's the 1. They're all in the way. And I is what you need to have alone on the right side. So what you do is you first divide by 5,300. What you do on the right, you must do where? On the left. So you divide by 5,300, goodbye 5,300. There it is, it's featuring here now. Then get rid of the surveillance camera. How? You take the root of the surveillance camera. If it is 5, you take the 5th root. If it is 8, you take the 8th root. Since it's 17, you are taking the 17th root. But remember, what you do this side, you must do where? On the other side. So there it is, 17th root taken as well. Now I have 1 plus I. I is nearly alone. 1 is in the way. It is positive. So you take the 1 over to the left, it becomes negative. please guys, this whole entire thing, you are subtracting 1. You don't put the -1 underneath the root. No, you keep the -1 outside this thing. Now I is isolated. I can now calculate the interest rate. This is where I grab my calculator, guys, at this stage, and I'm going to punch in everything that I have. So I'm going to do this. You see this button here? This allows me to choose the fraction option. But before I even do that, I am going to check here which ones have a root. There it is. I have a root there. And you see there's a yellow thing that will allow me to put the 17. So I'm going to say shift, and I'm going to say boom. All right, does that make sense? And then I'm going to go inside and boom. All right, press this button so that I have the fraction. Now outside, I'm going to go and punch in my 17. 1, 7. There it is, 17 as the root. Then inside, okay, I'm going to now go punch in the 11,291 rand 45. 11,291,45 over 5,300. 5,300. Then I move out of the square root to the outside. The outside has -1. I say -1. Make sure, guys, that the -1 is outside, not inside the root. Because if it's inside the root, it's going to change your answer. But the -1 is outside. There it is, right? Then you can press equal. You see what you see there? That is the interest rate as a decimal number. That is the value of I. It's not 0.4549507408408 . This is what we call an irrational number. It's irrational because look at the decimals. They are non-terminating. In other words, they don't stop. These decimals would go on forever. If our calculator was longer, you would see other numbers even after the 8 because this goes on forever. It's just that our calculator is limited. So this is non-terminating, and also there's no repeating, which means it's non-recurring. Okay, but then after this, we would take I, right? We take the I value, which is that whole entire thing. We times it by 100. Why do we times it by 100? Because we want the interest rate not as a decimal number, but as a percentage. So in order to get it as a percentage, I, which is a decimal number, which is the interest rate, you times that I by 100, which is that, so that you can get what? The interest rate as a percentage. So take this now, what I have in my calculator, I'm going to times by 100. What do I get? Equal. There it is. 4, what? 4,5 if I round off to one decimal place. The thing is, I go to my answers there. You can see all my answers are rounded off to one decimal place. Which answer fits the answer that I got here? Okay, it is A. And I can be sure that that answer is correct. Okay. There it is. And that's how I calculated it. Okay. So guys, and this is maths. This is GEC Maths. Okay. Right. So there, guys, from the top, where I calculated the A, you know, where I calculated, all right, I got N is 17, P is 5,300, okay. Okay, let me just reduce this and put it on the side. Okay, remember, you see, I got N is 17, P, which was 5,300, calculated the number of years, P is 5,300. the A value, remember, we were told that this person actually had shares, right, that they had bought, which were 5,300. And then they had bought the shares in March 2006. And then at the end of February 2023, they actually sold the shares at this amount of money. Okay, so now what we are going to do, that P value and that A value, we want to calculate the compound interest rate. So since the statement said compound interest, it means we're going to use the compound interest formula. P, there it is. A, there it is. Then we substitute the N, and then of course we're finding I here. And as I said, guys, if you want to find I, then it means you are going to be eliminating the 5,300, which is multiplied to that. You divide by 5,300 both sides. Then after that, you take the what? The 17th root to get rid of the 17, which is the surveillance camera. You do that both sides. You transpose the 1, and remember the 1 must not go under the square root. It is next to. And then ultimately, you have to multiply what you get here by 100 in order to get the interest rate as a percentage. R is the interest rate as the percentage. I is the interest rate as a decimal number. Okay, and that is our answer that we got, which is 4.5%. I know that was long. You see, that was long. And the reality is that, guys, that's why that GEC paper that has 60 questions is 2 hours, 30 minutes. Okay, because for some questions, you're going to have to really do calculations. Whereas for some questions, you'll read the question and be like, I know the answer. You'll be able to recall from memory, okay, what the answer is. But please, let's do things genuinely so that we don't lose marks unnecessarily, okay? Okay, so for instance, this next question, number 7, that's one of those questions where you can just tell me the answer. Negative A times B into E times negative G. Which of the following expressions is an example of the commutative property? What does the word commutative mean? Guys, commutative property applies to multiplication and addition. In other words, A times B is the same thing as B times A. The word commutative simply means changing the order, all right? You guys know that 3 times 4 is actually equal to 4 times 3. So no matter what the order is when we multiply, commutative just means that for multiplication and addition, the order in which you place your numbers doesn't matter. B plus A is the same thing as A plus B is the same thing as B plus A. Okay, just like 1 plus 3 is equal to 3 plus 1. That's what commutative means. Commutative property speaks to that. Now, what they are asking in this question, which of the following expressions is an example of the commutative property? You are given negative A times B into E times negative G. And they are asking there, which of the following expressions is an example of this the commutative property? Is it negative A plus E plus B minus G? Obviously, A is out. We don't even consider A. A is out, out, out. Let's look at B. Negative A minus G. Oh, come on, guys. All right. If you look at that expression in your bracket for number 7, okay, there's no minus, there's no subtraction of A and G. So B is out. What about C? Negative A times E into B times negative G. All right. Now look at the A. Number C there. Look at the A. For C there. A is negative E. B negative G. Look at this, guys. Isn't this the same thing as that? This negative A, right, is still negative here as well. Here it's multiplied with a positive e, but it would be the same thing because there's an e there that is also positive. This b is positive, just like the same thing b here is positive. Okay, then this g is negative, this g is also negative. Okay, and remember this e and this e are also positive. Now, all of this, guys, for your expression for the question is multiplication. And remember, what did I say about multiplication? Guys, multiplication is commutative. So it doesn't matter the order, right? Brackets mean multiply here. Negative a is multiplied by b, which is multiplied by e, which is multiplied by negative g. So all in all, as long as we have the negative a, the b that's positive, the e that's positive, the negative g that's positive. For multiplication, the order in which you place these does not matter. So therefore the answer is C. It's none of the others. It is not A, okay? It is not B. It is not D, but it is C. That is the answer, okay? Right, and then before I leave you guys in love and peace, okay, let me just do one more. If 1 kilometer takes 4 meters, multiply 4 by 10 kilometers to get 40 kilometers. I don't know which question this person, TSG, what are you referring to? What is TSG talking about? Struggling with number 5. I just explained number 5, TSG. I explained number 5. You're struggling with number 5. You're struggling because you want to. 2 ways of answering this question. First way, you can 6 kilometers, 2 took 6 kilometers to run 24 minutes. I mean, took 24 minutes to run 6 kilometers. The question is, if he runs at a constant speed, which we don't know, how much does it take for him to run 10 kilometers? So what you can do is you can use DST to calculate first the speed that Tudo is running. So firstly, your distance is 6 kilometers. He's running for how long? 24 minutes. But remember, kilometers and minutes, not compatible. So we convert the minutes of 24 to hours by dividing by what? By 60. Why divide by 60? How many minutes are there in 1 hour? There are 60 minutes. So we divide the 24 by 60. We get 2/5 hours, which is 0.4 hours. Then the speed, right? Of course, we can now calculate the speed. Speed is equal to distance over time. 6 kilometers divided by 0.4. What do we get? 15 kilometers per hour. That is the speed. Now, he's running at the same speed. So that means now we can actually go and calculate how long it takes for him to run 10 kilometers. We take the same speed. We go substitute now in a new formula where we have distance of 10 kilometers and we have the speed of 15 kilometers, which is the same speed that he's running. Now we're going to check how long does it take. So we use the formula T is equal to D over S. Time, distance is 10, speed is 15. The answer is 2/3 hours. That's the time. So it can't be anything else but that. Okay. So that's basically how we calculate, or that's how we get to the answer for that particular question. Okay. Hope we good. Hope we sorted. I hope we are okay. Okay, number 8. Let me just do this before I leave. Number 8 is saying, what is the additive inverse and multiplicative inverse of 1/5? Additive inverse is the number you would add to 1/5. That leads you to 0. Multiplicative inverse is the number that you would multiply with 1/5 so that you get what? So that you get +1. Okay. So I repeat, additive inverse is the number that you would add or subtract to 1/5 to get 0. Multiplicative inverse is the number that you would multiply to 1/5 to get 1. So additive inverse means the number you add or subtract so that you get 0 when you add or subtract to 1 over 5. Multiplicative inverse is the number that you would multiply to 1 over 5 that leads you to 1. I repeat, additive inverse, the number you'd add or subtract to get 0. Multiplicative inverse, the number you would multiply by a particular number to get 1. So if you look at A, if you take 1 over 5 and you subtract 1 over 5, you get 0. If you take 1 over 5, you multiply negative 5, you get negative 1. So A is not the answer. Let's go to B. If you take 1 over 5, you subtract 1 over 5, you get 0. If you take 1 over 5, you multiply by 5, you get 1. So basically B is our answer without even going any further. All the other options fall off and they do not satisfy the condition for additive inverse and multiplicative inverse. So as I said, guys, the number that you add or subtract to give you 0. Okay, remember we were given 1 over 5. So what can we add or subtract to 1 over 5 to get 0? We subtract 1 over 5. What can we multiply to 1 over 5? That will give us 1. That's the multiplicative inverse. We can multiply by 5 to get 1. So that's why our answer there is B, not A, not C, and not D. Okay. Good people, thank you so much for joining my live. I have to unfortunately leave you and love you. Take care of yourself. Please guys, like I said, go to my link in my bio. The link in my bio, go to Maths is a Game. The YouTube channel link is in my bio. Copy the link, paste it on your Google search engine, search it, find the YouTube channel, go and subscribe so that when I upload my videos and even the videos that I've done of live sessions in the past for GEC papers, I have playlists, guys, on my YouTube channel that can help you as you prepare for your exams. I love the feedback that I'm getting from some of you. I know the videos are not of great quality because I'm downloading the exact videos that I have done of the live sessions on TikTok, but they are helpful. If you are patient enough, you take the time, you actually really listen and listen to the content more than the quality of the videos. I'm sure you will gain a lot and your maths will become that much better. Thank you so much. Have a good day. All the best to those who are writing English today. I wish you all the best, and all the best to those who are writing other exams. I wish you all the best. You go get it. You go get it. I believe in you.